Good afternoon, students. Okay, today we'll be looking at diffusion. I think everybody should have had some experience of what is diffusion because I had given you guys an assignment to research ahead to find out what it is. So, we can now say that diffusion is the movement of particles from a high concentration to a low concentration along a concentration gradient. This is the example that I would like to use in order to illustrate to you the process of diffusion. Okay, I'm going to start with a perfume bottle. So I'm going to draw my perfume bottle at the side here. Might not be too accurate, but it is basically the perfume bottle. Okay, what is going to happen is that my perfume bottle will be sprayed, and when it is sprayed, the dots are going to represent the particles that comes out of the bottle, right? But if you notice, right at the entrance of where the particles are coming out, there's a great amount of particles there. So this would now be considered as having a high concentration at this area. So if there's a high concentration at this area, remember that they said that diffusion is the movement of particles from a high concentration, so where a region where there are many particles, right? So right at this point now, what we're going to be doing is that we want to see the process of diffusion taking place. So if there's a high concentration, that means there's going to be a concentration gradient. Firstly, we would like to find out what is a concentration gradient. Okay, have you ever seen a seesaw? So a seesaw looks something like this. If you were to put a weight onto the seesaw, a big enough stone, what will happen to the seesaw? The seesaw would basically look something like this, right? So this is basically the same process that occurs in diffusion. So what happens is that whenever there's a high concentration of something, it basically creates a gradient. So the gradient is basically a slope. So now, in order for diffusion now to take place, the particles now have to cross in order to be evenly distributed. So in order for this to happen, the particles now would have to spread out. So when the particles spread out, what you'll find is that they're going to move from an area where there are many particles to an area where there are little amount of particles, right? So this time now they're going to spread out and go into all directions, right? So when they do this, after a while, what you're going to be finding out is that the particles are going to be evenly spread out. So now there will not be any concentration gradient that is that significant. It will be an even distribution of the particles, right? So it would be something looking like this. Okay, so after that has happened, we can say that diffusion has now taken place. Okay, imagine yourself mixing a jug of Kool-Aid. Whenever you pour the quenchade into the jug, you notice that the Kool-Aid or the product of the Kool-Aid basically stays in one location. If you allow it to stay there, what will happen is that the high concentration of the particles in one area will eventually spread out to the other areas. So this now here in this particular location, what is occurring in this thing is now called diffusion. So diffusion now is the movement of particles from an area where there are many particles to an area where there are less particles, right? So basically what will happen is that after a while the quenchate particles will be evenly distributed. Hence, you will have a solution that is fully distributed in terms of the particles, and the quenchate color will be evenly distributed in the container. So now you would have a mixture or a solution